Here's an example of a problem that is much easier to solve using the concept of moles of reaction. Okay, and in this uh, example, we're going to illustrate how you can use what's called an ice table to set up the problem. And ice simply refers to the three rows that you need to set up in your table. You set up a row of initial values for your moles, and then you set up a row of changes in the moles, and you set up a row values for the ending amount of moles as in the problem. Okay, so let's look at this particular question right here. Suppose you have 1 mole of H2 and 1.5 moles of N2, and you allow them to react. So this is the reaction. 3H2 plus N2 gives you 2NH3. And sometime later, okay, you found that you now have 2.3 moles of gas molecules in your reaction mixture. So this 2.3 moles, okay, this would be not just N2 or H2 or NH3, it's a combination of all three. So this is going to be N2, H2, and NH3 all combined. You have 2.30 moles of gas. So the question here is, how much H2, N2, and NH3 are in the final mixture? At the point where you got these match you got 2.3 moles of gas, how much of that is H2, how much of that is N2, and how much of that is NH3? So we set up our ice table here. So our initial moles you have, so for H2 you have 1 mole initially. Okay, here's 1 mole of H2. And for N2 you initially have 1.5 moles. Okay, and since you're just putting H2 and NH2 together, so initially you don't have any ammonia, so ammonia NH3 is 0 moles. Okay, so that's your initial conditions, you would say. Now, using the concept of moles of reaction, then you know that this is you're gonna lose 3x moles of H2. Coefficient of H2 is 3. The change in moles of N2 would be 1x. So you're going to lose x moles of that. The change in moles of NH3 would be 2x, so you're going to make 2x moles of ammonia. Okay? And so that would be in general. And we're looking for the situation where x is such that the total moles would be 2.3 moles. So let's see. How many moles would we have of H2 now? After x moles of reaction has occurred, then it's going to be the starting amount minus the change. So 1 minus 3x moles. Okay, remember you're going to lose H2 during the reaction. Okay, and you have 1.5 moles of N2 to begin with. You're going to lose x moles of N2. So and in the end, you're going to have 1.50 minus x moles of N2. And in ammonia, in the case of ammonia, you start up with 0, you make 2x, so you're going to end up with 0 plus 2x moles of ammonia. So, finding out how much N2, H2, and NH3 you have at the end is just a matter of finding out what x is. Well, let's read the problem and see if we can set up an algebraic equation to solve for x. It says you have a total of 2.30 moles of gas. Well, you have this many plus this many plus this many. All of that should add up to 2.30. So what you do is you say moles of H2, which is 1.00 minus 3x moles, plus moles of N2, which is 1.50 minus x moles, plus 0 plus 2x, let's just call that 2x moles of NH3. All of that should add up to 2.30 moles. Okay? Those are your gases, N2, H2, and NH3. And you can see I can combine all these. I can just say, combine all of this. So this 1.00 minus 3x plus 1.50 minus x plus 2x moles. I can factor out moles there, and this is equal to 2.30 moles. So I can just cancel moles, so I can solve for x, right? So let's simplify this. 1.00 plus 1.5 is 2.50. negative 3x, negative x, that's negative 4x, plus 2x, that's minus 2x, equals 2.30. Okay, so subtract 2.50 from both sides. You have negative 2x equals negative 0. So this 2.5 cancels out. 2.3 minus 2.5 is 0.2. So negative 2.20. Divide both sides by negative 2. So x equals positive 0.10. Okay? So now that we know that, then we can just say how much H2 do we have at the end? Remember, to start off, we have 1, you lost 3x, so now you have 1.00 minus 3x. Moles of H2 is 1.00 minus 3x. So that's how many moles you have. So 1.00 minus 3 times 0.10. That's how many moles you have. 1 minus 0.3 is 0.70 moles of H2. And for nitrogen, moles of nitrogen is equal to, what did we have to begin with? 1.5, you lost x. So 1.50 minus x moles. Okay. And so you have 1.50 minus 0.10 moles, and you end up with 1.40 moles. Finally, NH3, moles of NH3 equals 2x moles. So this is going to be 2 times 0.10 mole, and so that's 0.20 mole. And let's verify if we have all the numbers correct. If we add up all of these numbers, we should get 2.3, right? So moles and H2 is 0.70. This is your H2. Plus moles of nitrogen is 1.40. Plus moles of NH3 is 0.20. That should add up to, let's see, 0.7 plus 1.4. That's 2.1 plus 0.2. That gives you 2.30 moles total.